page 18 in your P2. Now, first of all, I'm going to go through and I'm going to give you just some basic rules. So it's going to look like I'm just kind of skipping over some stuff, and I really kind of am, but I'm going to give you some basic rules, and then we're going to get down to the meat and potatoes of how you'll see these problems in the examination. So basically, if you look on page 18, we had this before. Now, with a show of hands, if anybody looks at this, particularly this one right here, does that confuse you at all? That y, an absolute value of x, could equal a negative x? Yeah, okay, I'm seeing some heads nod. So, let me work through some numbers with you to help you see this, because we've always been taught that absolute value is distance, right? And distance is never negative. So it's just your distance from 0 on the number line. So let's look at this one first. This is saying if x is greater than 0. So give me a number greater than 0. Let's say x is what? Okay, 2. So if I do absolute value of 2, all right, now look, everybody look up here, because this is where it's going to get you. I substituted what in here? 2, and I'm going to get 2. Not because I know the rule that absolute value of 2 should equal 2, but because I substituted it in for a value of x. Everybody follow me so far? We know absolute value of 2 is 2, but the main thing I want to understand is I put in a 2 here, and x is still 2. Now let's see how this works for the second one. All right, this is wanting a value of x less than 0. I'm going to pick negative 3. Now, we know, everybody, right, the absolute value of negative 3, is equal to 3. Yes, we know that. Well, what this is saying is, what is my x? What is my x? 2 negatives make a positive. Okay? Does that help clear things up as to why this rule reads the way it does? Okay? I have to substitute. You don't do negative 3. You do negative 3 because that's what I chose for my x. Okay, so I just wanted to clear that up for you. You know what absolute value is, but guys, I'm going to tell y'all, when you hit college, you may have professors that say, read this and understand it. And they're not going to teach it to you. One of the best things you can ever do is to try to substitute numbers in and see if it will then make sense to you. I have to do that all the time. So there's no shame in that, but you've got to start learning to read these theorems, these examples, these definitions, the way that they're written, and learning how to apply what you know. So let's look. The next place we want to look is on page 20. Okay. So turn to page 20. This is very basic. I still want to hit the high points though. In the gray box at the bottom, if you have absolute value of A times B, it is the same thing as the absolute value of A times the absolute value of B. Now let's think about it. Let's make A a number. A would be, let's make it 2, times negative 5. So that would be negative 10, and the absolute value of negative 10 is 10. Okay, we're working it out with numbers. This is what I told y'all I do, so it makes sense. So here, we're saying this is equivalent to my A is 2, my B is negative 5. Absolute value of 2 is 2. Absolute value of negative 5 is 5. And 2 times 5 is 10. So all they're saying is that if you have two separate absolute values, you can multiply them together. Okay, the same rule about division. If you have absolute value of A divided by B, it's the same thing as absolute value of A divided by absolute value of B. So if I have negative 15 over 3, that would give me negative 5. That would result in 5, or absolute value of negative 5. So if I took absolute value of negative 15 divided by absolute value of 3, that becomes positive, and I still get the same answer. As long as B is not 0, because we know we can't have 0 in the denominator. Okay, looking on page 21, there's a little gray box on page 21. And all it says is the distance between points A and B on a number line is absolute value of B minus A. You could do A minus B on that. You're still going to end up with a negative. It's going to end up positive. Look at page 22. Now, this is the written example of solving absolute value equations. This is the written example of solving absolute value equations, which y'all did last year. So if A is greater than 0, in other words, A is what? Positive. Greater than or equal to 0. In other words, A is positive. Then you could have the absolute value of X is less than or equal to A, which is equivalent to, two little arrows, negative A less than or equal to X less than or equal to A. Remember, that's less than and. Okay, so let's work an example of this. So I'm going to let X be less than or equal to 5. Why does it say that A has to be greater than or equal to 0? Why do they put that in there? I want to see who my deep thinkers are. Why is this part of this definition? A cannot be negative. Can I put any number here and have X absolute value of it resulting in a negative? Can I ever? No. So that's why that little piece is in there. So you had this, and this is like one of the very first problems you ever get when you're learning absolute value. And what you do first when you have a problem like this is you drop the bars. Then you have to have two of these because, guys, absolute value is what shape? Now that's a cubic. Absolute value.
Oh,
V. So, guys, everybody look up here. I'm fixing to graph the absolute value of x. Okay? There's absolute value of x. So if I've got f of x equals that, and f of x equals 5, 5 would go through something like that, right? So that would be y equals 5. How many places do those cross? 2. That's why you have two answers on the absolute value. Okay, because it makes the v. And if you were to set these two, like if you put this in y1 in your calculator and this in y2, they're going to intersect twice. Okay, so the next one is I do x. I change this answer over here to a negative, but when I do that, I have to flip the inequality. Now, this was a less than and. How do we always write less than ands? Together or apart? Together. Which one of these is the lower of my two numbers? So I put negative 5 less than or equal to x less than or equal to 5. Guys, look at this part right here. Less than the 5. The part less than the 5 is between these two. The underneath part. Okay. So now let's look at the next rule on that same page. It looks a little more complicated. It is not at all. So if a is greater than or equal to 0, in other words, a is positive, has to be, then x minus k is less than or equal to a is equivalent to k minus a less than or equal to x less than or equal to k plus a. Just write that down. We're going to plug in some numbers in a minute. So our a has to be positive here. If it was negative, this wouldn't work. You can't do it. So I'm going to have, let's say I'm going to use 3 for my k, and I'm going to use 4 for my a. Now pay attention, you're going to have to do this in class in just a minute. Now how do I solve this? Drop the bars is one of them. Remember, this is my k, that is my a. How will I solve for x? How will I solve for x? Add 3, that is my k. So I have 4 plus 3, yes I have 7, but I have a plus k. Is that the same thing that I've got right here? Alright, now I'm going to solve for the other one, which means I keep the bars dropped, make the 4 a negative, and flip the inequality. This is my k, this is my a. I'm going to add the 3, this is my a, that is my k. So I've got negative a plus k. So I have this part. Now you may say, oh, your inequality's backwards. No, it's not. I read it from the x. I always read it from the x. So x is greater than negative a plus k. X is greater than negative a plus k. So while that looks extremely difficult in that definition, you've been doing it for some time. Okay, any thoughts or questions about that proof or that definition? Okay, we've got a couple more things to go over and then we'll work some problems. Look on page 25 at the very bottom. If x is any real number, this is going to become important, then x squared is equivalent to x squared, which is equivalent to x squared. All of these are equivalent. It doesn't matter whether your square is on the inside or the outside. Now, didn't I go over a rule with you a minute ago that said a times b, or x times x, is equivalent to x, absolute value of x, times absolute value of x? Did I not just go over the multiplication rule? So the same thing works if you've got the same number. Okay, this is going to be important in just a minute. All right, flip over to the next page, page 26. The square root of x squared is equivalent to the absolute value of x. Now, this is not a notation that I see all the time. I've seen it once in a while. But sometimes you will see answers in the back of the book that if you had the square root of 3 squared, it will give you the absolute value of 3. And you might be going, why did they put the absolute value brackets there? Because they want the positive answer. They want the positive answer. Okay, the last thing before we start doing work, the bottom of page 26. If you have the absolute value of a, and absolute value of x, and it equals the absolute value of a, then this is equivalent. This right here is the meat and potatoes of this lesson, right here. If you have an absolute value on the left side, it is equaling an absolute value on the right, then that's equivalent to the square of the left equaling the square of the right. Now, the same thing applies for greater than. It is also equivalent to the less than, as long as a is not equal to 0. Because once again, it can't be set to something negative. Or it can't be set to something 0 in that case. Okay. Now, let's use this. These are just some of these rules that you're going to have to remember. But look at the top of page 27 and write down example 2.7.2. We've got the absolute value of x minus 2 is equal to the absolute value of 2x minus 1. This is the rule we just learned. Now, what did they tell you you can do to that it is equivalent to? squaring both sides. So what we're going to do with this is we square both sides. Now guys, this is one problem that I can tell you when you see it on the examination, they do not change it. It looks exactly like this. So we really want to understand these. So you go ahead and square both sides. Okay, so what do we have here that we are recognizing? Quadratic. Guys, now typically this is an equation because these are equals, not inequalities. So I can move this either way I want to, but just for the sake of keeping it go ahead and go to your polysolve and find me what the two values of x are. Okay, everybody make 1 and -1 should be. See what you typed in. You may put a 3 as your B instead of C. Everybody get 1 and -1. Be careful putting in your A, B, and C. That's the only thing. It's happened to me too. Okay, that's it. That's the solution. Nothing else to do on that. Okay? So let's look at the example underneath, the 2.7.3. What is this one, an equation or inequality? Inequality. Looking back at the rules I just discussed with you, absolute value of x greater than or equal to absolute value of a, how did they say we can solve it? Square both sides. So I'm going to start squaring.
You just get rid of the bars and then you.
Now there's something that we talked about yesterday. This is an inequality. So am I just going to solve for x and get x equals x equals? What do I have to use? The sign chart. That line. Anytime we have a quadratic inequality, we have to do what you got quizzed on today. So Addison and Emma, you can watch my video. This is the same review. Okay? So the one thing we talked about yesterday, when we have an absolute value inequality, and we've got things on both sides, we can move it all to the left, we can move it all to the right. But if I move them all to the right, I have to be extra careful. Because I'm looking for negatives here instead of positives. So let's move it all to the left. So go to your PolySolve on your calculator and come up with your two roots. What are my two roots? 1 and 5/3. Okay? Now, for those of y'all who have been absent, once you get your two roots, you've got 3 sections. You've got 3 roots, you have 4 sections. So you want to do a test point. 0 would be a great test point here. Get negative. You have to do something between 1 and 1.6 repeating. So 1.5 would be good. You have to do something greater than that, so 2 would be good. I think it's negative, positive, negative. Now looking at this and reading from the x, x is greater than or equal to 0. So that means I want which sign? Positive. So I write this because it's in between. I think there's some people still questioning how you write these and you're not asking me. So 1 less than or equal to x less than or equal to 5/3. If it's between two numbers, it's always less than, put an x less than. If it's equal to in the problem, you put equal to. That is your answer. Anytime you have a quadratic inequality, this is how you solve it. Okay, questions for me? All right, this is your classwork. When you get done, turn it in. If you don't get done in class, then you will solve it. You will work and finish it at home. So page 28, you're going to do 1 A, C, E, G. You're going to do number 2, E, G.